All right, this is a video lesson for Unit 3, Lesson 2, which is two-step equations. So a little bit of a step up on what we were doing before. We are now not just going to have one thing to do in a problem, but multiple things to do. This is part of the target. I can solve multi-step equations. This target will be covered in a couple of lessons because we'll start off with two-step, and then we'll move into problems that have even more than two steps. First thing we want to do is remember our order of operations, which is PEMDAS. You know, I like to call that PEMA. We're actually going reverse order of operations to solve. So this was for expressions, and what we're doing now for equations is we're going backwards. I like to call this PEMA, I like to call this AMAP. It's the reverse of PEMA. So instead of ending with addition and subtraction, we're going to start with addition and subtraction. Then we're going to deal with multiplication and division. Then if there's exponents, we'll deal with that. And if there were parentheses, we'll deal with that last. So it's a complete flip on order of operations. That's not to say order of operations were wrong. That's the right way to simplify something. We're not simplifying anymore. We're solving. So it's a different method. So first problem that we're going to do is 2x plus 7 equals negative 5. We're going to start off in AMAP with addition and subtraction first. So we're going to subtract this 7 because this plus 7 is keeping the 2x from being alone. We're going to subtract this 7 first. So I'm going to subtract 7. If I do it to one side, I'm going to do it to the other. Now that there's a little bit more work going on in these problems, I like to do something called drawing the river. That's what this is. It just helps me keep organized and remember my equal sign. So the 7's are gone, and we have 2x remaining, equals negative 5 and negative 7 are going to make a negative 12. Now we're down to a one-step problem. I'm multiplying my x by 2. I want to get rid of that, so I'm going to divide by 2. If I do it to one side, I'm going to do it to both sides. Now we have just x equals negative 6, and we are solved. Problem over. Number 2. We want to take care of this addition and subtraction first. So I'm going to add 6 to both sides. I'm going to have negative 4x left. I'm going to have 20 on the other side. So negative 4x equals 20. I don't like that negative 4, so I'm going to divide both sides by negative 4 since this was multiplication. Some of you are going to want to add 4 because you see a minus 4, but that's a negative 4 being multiplied to x. So we're going to divide by negative 4. And if we do it to one side, we have to do it to both sides. So we're left with x equals, and we have 20 divided by negative 4, which is negative 5. X equals negative 5. And that's our final answer. Number 3, you're going to notice that this is going to have a little bit of an extra level of difficulty to it. So we have that negative 2 we want to get rid of, so I'm going to add 2 to both sides. It's going to give us negative 3 halves x. Notice, well, let's finish. 9 equals 9. Notice for this problem that I slipped the negative sign up to the top. Instead of writing it off to the side, I wrote it up top. I really like doing that. It makes it easier to work with these numbers. Now I'm going to multiply both sides. If you remember from last lesson, I'm going to multiply both sides by the reciprocal. So I want to get rid of that 2 on the bottom, so I'm going to put a 2 on the top. I want to get rid of that negative 3 on the top, so I'm going to put a negative 3 on the bottom. That's going to get rid of the negative 3's and get rid of the 2's, just leaving us with an x. But if I do it to one side, I have to do it to both sides. So I multiply over here by 2 over negative 3. Well, 9, some of you will get confused here, so put a little 1 underneath the 9. 9 times 2 is 18. 1 times negative 3 is negative 3. And when you simplify 18 over negative 3, you get x equals negative 6. And that's your final answer for that problem. Number 4. We're going to subtract the 9 right away. We're using AMAP. We're trying to get rid of that 9. We want to subtract 9 from both sides. And we're going to get 1/4 x equals 2. Well, I want to get rid of that 1 over 4, so I'm going to multiply both sides by a 4 over 1. Gets rid of the 4, gets rid of the 1s, just leaving us with an x. But if I do it to one side, I got to do it to both sides. 4 over 1, and really this is a 2 over 1, which makes 4 times 2, 8 over 1, which is really just x equals 8. Got 2 examples left. One's a little tricky, and one has just a part of it that people make a lot of mistakes on. So for this problem, this is number 5. One thing people don't realize is there's little sneaky parentheses here. It's implied parentheses, so they don't show up in the problem, but they're actually there. It's whenever you have a whole side divided by a number, you actually have implied fraction, or an implied parenthesis within that fraction. So parentheses in a map, if I rewrite a map, parentheses are the last step. So we don't want to do that first. There are no, you might say, oh, there's addition, but the addition's within parentheses. So there's no addition or subtraction to deal with. We're going to deal with the multiplication or division. This negative 4 on the bottom down here, I want to get rid of this. So I'm going to put a negative 4 on the top. I'm going to multiply by negative 4. That's going to get rid of the negative 4, but if I do it to one side, you know the drill, I got to do it to the other side. So we're going to have n plus 2 equals 13 times negative 4, which is negative 52 if you use a calculator or your head. Now I want to get, well, this is weird. You know, I had parentheses in the last problem. I didn't even write them this time. But the thing is, I don't even need them. Once the thing in parentheses is the only thing on a side, you don't even need the parentheses anymore. So what you realize is you never actually get to P in AMAP. You never actually get here because the process of doing the first 3 steps actually ends up eliminating the parentheses. So we're out of parentheses. There's no parentheses in this problem, so we're just going to subtract. Subtract the 2, subtract the 2, n equals negative 54. So there were implied parentheses in that problem, but once we multiply both sides by negative 4, the parentheses went away, and then we were able to just use addition and subtraction. Now, this problem. I bet most of you, and I want you to try this problem, pause the video, and then come back and check to see if you did right, because I bet you make a little mistake here. So what happens on this problem for a lot of people is they subtract this 8 to get rid of it, which is right. That's what you want to do. You want to get rid of this 8. So you're going to subtract 8. You do it to one side, got to do it to both sides. So I subtract 8 here, and I have negative m equals negative 21. This guy gets lost a lot. People forget about it. So make sure that that negative sign's there. Now the thing that we're not seeing in this problem is a little 1. It doesn't need to be written, but it's important to know it's there. Because now when we say, well, how do I get m by itself? We're going to divide by negative 1. And that's going to make that negative 1 go away. Boom, gone. But if I do it to one side, I got to do it to the other side. So I have m equals a negative over a negative is a positive, and 21 over 1 is 21. So m equals positive 21. And that's our final answer.